Okay, so let's take a look at your questions with critical angle. On the textbook on page 410, number 12 says, determine the critical angle for ethyl alcohol. So our equation is sine theta c, is equal to N2 over N1. And whenever they don't tell you what the second medium is, you always assume it's air. So the critical angle for ethyl alcohol means ethyl alcohol into air. So N2 is air, 1.00029, and ethyl alcohol, we know, is 1.362. And this gives you 0.7344 for sine theta. Do the inverse sine and get 47.259 degrees for the critical angle. Number 13. The critical angle for a new kind of plastic in air is 40 degrees. Okay? So we have theta c and we have N1 because they told, or excuse me, N2 because they said for in air. So from that we can find our N for this new type of plastic. Do sine theta c is equal to N2 over N1. So N1 is equal to N2 over sine theta c. So 1.00029 divided by the sine of 40. And you should get an N1 of 1.556. But that's not what the question asks. The question asks, what's the critical angle for this plastic if it's immersed in water? So now they're saying you're putting it in water. So the new N2 is 1.333, and it wants the new sine theta, or the theta c. So we know theta c is equal to N2 over N1, and this time my N2 isn't air, it's water, because they've told me. And the N1 is what I just found, 1.556. So I'll get my sine theta c, and then I'll take inverse sine of both sides. So before the inverse sine, it's 0.8566. Take the inverse sine, and it becomes 58.936 degrees. Okay? Number 14 says, optical fibers made of a core layer surrounded by cladding trap transmitted light by ensuring that the light always strikes the core cladding interface. So this is our total internal reflection that we were talking about. Right, so it's going to come up here, strike at an angle bigger than the critical angle, and go down. This is the core, this is the cladding. And the question wants to know, calculate the critical angle. So we know sine theta c is equal to N2 over N1. The cladding is going to be 2, the core is going to be 1. You're going to look it up in your textbook in the chart, and when you do, you'll see the index for cladding is 1.47, and for the core it's 1.50. So this will be 0.98. Take the inverse sine of both sides and get 78.52 degrees. Okay? All right, that was it from the textbook, but now we also had some from your sheet. So number 8 to 11 in your sheet. So number 8 says, an incident ray of light makes an angle of 30 degrees with the surface of a glass plate. So we're back to Snell's law now. Okay, so we have our incident ray coming in, but be careful. It says makes an angle of 30 degrees with the glass plate. That is not my angle of incidence. My angle of incidence is this guy, 60 degrees. Okay? And the glass plate has an index of refraction of 1.55. What is the angle between the refracted ray and the surface? So we can find our angle of refraction, our theta 2, but then it actually wants to know what's this guy going to be. And doesn't tell you, so you assume the other medium is air. So N1 sine theta 1 equals N2 sine theta 2. We're solving for theta 2. So divide both sides by N2. Fill in your values. N1 is air, so look it up in the chart. If you don't already know, it's 1.00029. Sine of 60, because it has to be the angle with the normal, over 1.55. You will get a sine theta 2 to be 0.5589. Take the inverse sine and get theta 2 to be 34 point something degrees. This is not your answer though. It wanted the angle with the glass plate. You have to take that away from 90, and so therefore 90 minus 34. And I think your final answer is 56.04 maybe degrees. Oh, 02, sorry. 02 degrees. All right, number 9 also has a little trick in it, because number 9 says light strikes a glass plate at an angle of incidence of 65. That seems fine. Maybe I'm wrong. So this is 65 degrees. Part of the beam is reflected. Part is going to come back up here. And remember, the law of reflection tells us this angle also has to be 65 degrees. And part is refracted, so part's going to come down here, and this will be our theta 2. It is observed that the reflected and the refracted portions make an angle of 80 degrees. So this angle is 80 degrees. So if this is 65 and this is 80, that's 145. So how much does theta 2 have to be? Hopefully you can see it has to add up, remember, to 180. This has to be 35 degrees. What is the index of refraction of the glass? So you're looking for N2. So N1 sine theta 1 equals N2 sine theta 2. N2 equals N1 sine theta 1 over sine theta 2. So the only trick in this one was find your theta 2. And you have to do a little geometry to get that. So again, it's air times the sine of 65 over the sine of 35. And when you do this, you should get 1.58. Okay? Number 9. No, that is number 9. Number 10. What is the critical angle? Sine theta c equals N2 over N1. For what is the critical angle for light traveling from glass into water? Into water. Water is your second one, 1.333, and it tells us in the question that the glass is 1.5. Okay? And so when you do this, shoot, I don't have it here in front of me. How did that happen? Oh, wait. You should get a theta 2. I have the answer, though, of 62.706 degrees. Okay? Number 11. Number 11, calculate the speed of light. So I wanted you to go back and use n equals c over v just because you hadn't really used it. So v is going to equal c over n. For A, 2.9979 times 10 to the 8th meters per second. And for A, it's ethyl alcohol, so 1.362. For B, V equals C over N, 2.9979 times 10 to the 8th meters per second. And it's flint glass. I need my chart. And I'll get that in a minute. And then C is crown glass. So C over N, 2.9979, 10 to the 8th meters per second over crown glass. How much time do I have left? I'm going to run out here. Where'd it go? Why can't I find it? It is nowhere. Where's my chart? Speed of light. There it is. All right, so flint glass is 1.65 and crown glass is 1.52. And so when you do this, you should get, for this one, 2.201 times 10 to the 8th. For this one, I'm reading it off the thing, 1.8